Okay, I think we're good to go. 133 people so far joined in. Thank you so much for being here with us. We really appreciate you guys taking the time to join us for this webinar with Emily Shashelsky from MicaSense. She's the sales manager, the sales channel manager for North America. She's been with MicaSense for 4 years. She's great, and I wanted to thank her for being here with us. And with that being said, we will hold questions until the end of the presentation. We will try to get to as many questions as possible. Unfortunately, if we're not able to get to the questions by the 2 o'clock cutoff, then we will just go ahead and answer via email. And hopefully we can get you all taken care of with whatever questions you may have. And with that, Emily, I'll let you go ahead and start. And thank you very much for joining us again.
Awesome. Yeah, thanks, Giovanni. I'm excited to be here today with everybody to discuss our product lineup. So we'll be going over the 3 different multispectral sensors that we carry and go over some sample data and give you a sense of how each sensor is best used. So let me switch to the next slide here. So the agenda, I'll start off with a brief overview on multispectral for those that are already familiar. And then I'll go into the product lineup. I'll close it out with some options for drone integration, since there are a variety, and then options for data processing as well, as far as the software side. So MicaSense is a company. We've been around since 2014 when the first RedEdge model came out. And we design our sensors in Seattle. We manufacture in Seattle as well. You can see we've got a small team here. So the reason we're able to be such a global brand is because of our strong reseller network. So we're represented in 60 countries. Drone Nerds is our premier partner in the US, and excited to be doing the webinar with them today. One thing that makes our products a bit unique is that we're platform agnostic. So that's both on the drone side and the software side. So we do keep that in mind when we're expanding our product line and designing new sensors, is keeping the weight and the form factor size minimal, or as minimized as possible, to be flown on a variety of different drones. We also have mounting points on the back of each camera and on the back of the light sensor, which lend itself to our integration kits, as well as any kind of custom integrations that are generated. And then on the data processing side, we work with a variety of different third-party software providers. So we keep the data pretty open, and we work with those partners to make sure that they're utilizing all the metadata from all the images and doing things like the radiometric calibration. So brief overview on the multispectral. We've got a great little graph here, or chart that shows it's a good overview. So essentially what multispectral is measuring is the light that is reflected off of a plant canopy. So the sun is beating down, that light is either being absorbed by the plant and used for photosynthesis, it's getting transmitted through the leaf, or it's getting reflected back up. So that last portion, what's reflected back up, is what we're most interested in. And the majority of that light is actually going to be non-visible. So near infrared light that we can't see with the human eye. And so the changes we can see in that non-visible portion of the light spectrum are what's going to help us get a sense of plant stress before it's visibly, showing up to the human eye. So this chart at the bottom here is a good indicator. It shows the typical reflectance curve for a plant. So in green, you can see a healthy plant. We've got a bump in reflectance for green. That's why we see it as green. And then we see not as much reflectance in blue and red. And that's because the plant is majority absorbing that light for photosynthesis. And then the huge increase for the non-visible light. When a plant is stressed, you can see with the dotted red line there's a change in that reflectance. So we're going to see an evening out in the visible. That's because the plant is not absorbing as much red and blue light. There's also going to be a decrease in reflectance for the near infrared. Looking at that chart again and kind of laying over where the bands on the red edge are, you can see that they're at those key kind of points for the typical reflectance curve. So we've got the blue, the green, the red edge, which is kind of right at the edge between the red and the near infrared, and then the near infrared band. So we're able to use the information from all 5 of those bands and then enter those into different vegetation indices, which are basically just formulas that are utilizing the band information. You can also create false color composites to get more information as well. So essentially taking that non-visible light band and assigning it a color. As far as the vegetation indices, NDVI is pretty common. So just to show you there how the bands are used, we're using near infrared and red. And that's going to give us information on plant biomass. So it's good to use early on in the growing season as the crop canopy is growing, to see any areas where plants aren't growing as expected or as much as plant surrounding. And then as the canopy matures, you're not going to be able to see as much variation with NDVI. Those values will get saturated. So at that point, it's good to switch over to something like NDRE, which is utilizing the same formula, except you're switching out the red band for that red edge band. So that red edge band is more correlated with chlorophyll content. So it'll allow you to see more subtle changes in plant stress due to water stress or pest pressure, whatnot. As far as radiometric calibration, that's an important consideration when you're looking at multispectral imagery of any kind. And that's because for the multispectral mapping, you're generally doing a time series analysis. So it's not going to be just one static image or map that you're looking at. You're going to be comparing it over time to look at the succession in plant growth, any changes and whatnot. And so in order to have confidence, for instance, that when you're looking at between the first flight and the second, the changes in NDVI, that's because of plant growth and not because of changing lighting conditions between flights. So the way that we're able to calibrate the data is using both a panel and a light sensor. So I've got some images there of both. Both of those are used in combination with each other to get a robust calibration for the data. And those are things that come included with all of our camera kits. We're taking a capture of that panel before the flight. So we've essentially, that white material of the panel is, we've, know the reflectance values in the 5 channels for that panel. So we can use that as a reference. And then the light sensor has those, the white dots you see there are all the different irradiance sensors. So there's 12 in total, and they're all at slightly different angles. So that allows us to not only be looking at measuring the irradiance every time the camera is capturing, but also determine where the sun angle is in relation to the drone. As far as lighting conditions for the multispectral flight, ideal lighting conditions are going to be consistent. So either sunny or completely overcast. What you want to avoid typically, because it's going to be hard to correct for, is areas where you've got large clouds that are rolling, over the field and going to be casting deep shadow on some areas, where keeping other areas sunny. So that stark difference of having kind of popcorn clouds, as we call them, is what's going to be most difficult to calibrate. Another consideration is to avoid deep shadows. So whether that be from trees at the perimeter of the field or the plants themselves that you're looking at, if they're tall. So to avoid the deep shadow, we recommend flying within 2.5 hours of solar noon. And then another consideration is taking the panel capture before the flight as well as after. So that gives you some flexibility when you go to process as far as which you'll use. You want to use whatever is more indicative of the entire flight. So if it was majority sunny and then started to get overcast at the end of the flight, you can use the first panel capture, for instance. And then when you go to process the data, typically the processing softwares will give you an option for what do you want to use for the calibration? Do you want to use the panel, or do you want to use both the light sensor and the panel? So our recommendations there are to, on a sunny day, use just the panel, because you're going to have the changes in illumination are going to be very slight. So you can just use that, the panel shot. In a overcast situation, you're going to have a lot more variability to correct for. So that's where the light sensor really shines. And so we recommend using both the light sensor and the panel in those situations. This is a good example of how the light sensor can be used. So we've got an overcast sky here during this flight, You can see there's a little areas where the clouds are a little bit thinner. So what ended up happening was the clouds kind of parted briefly during the flight, and it generated this sunspot at the edge of the field. So that's something we were able to easily correct for by enabling the DLS2 data when we went to process. All right, so as far as the sensor suite, I'll go into each discussion about each of the sensors, the hardware, as well as some data examples. So I'll start off with RedEdge here. So RedEdge is our flagship product, and the MX version is the latest model. So some recent updates we've made, we expanded the storage capability for RedEdge. So it used to be a 32 gigabyte SD card that came with the kit. It's now 128. So expanded that capability. We've also reduced the size of the reflectance panel. So it used to be much bigger. It's now just basically the size of that white reflectance target for easier transportability and carrying around. So that comes with all the kits now as well. And then with the RedEdge, you're going to get those 5 multispectral bands at a resolution of 8 centimeters per pixel at 400 feet. As far as sample data and outputs there, you're going to be able to combine the first 3 visible bands to get a RGB composite, and then using the rest of the bands to create different vegetation indices. So this is a good example of how RedEdge can be used. Essentially as a targeted scouting tool. So in this case, we've got a large tree fruit operation, and in these plum blocks, specifically, they wanted to fly to assess uniformity. So in this case, they were able to fly and see, the majority of the field is pretty uniform. We're seeing high values in green there in the chlorophyll map. However, pretty surprisingly, the last 4 rows are really low values showing up as red. So that's something where the farm manager might have expected that for the end row, just because of dust and whatnot that gets kicked up as vehicles are going on in that road. But it was surprising to see the low values for those additional 3 rows. So the one difference there was that those rows were irrigated with a different water source. So they immediately decided to first test that water and found that it was really high in salinity. So that was what was affecting the trees and starting to make them chlorotic. So we're able to pick up on that before they started to yellow. So you can see the area in RGB and how it looks green and healthy to the naked eye. So they were able to switch out the water source, and within a couple of weeks, the trees were able to recover. So able to take action there before there was kind of irreversible damage. Another great use for this RedEdge imagery is for insight around fertilizer applications or any other kind of input management decisions. So for planning as well as monitoring post-application. And we've got 2 good examples of that. So one on the left-hand side here is a rice field in Argentina. And the grower was using a third-party operator to apply nitrogen. So they wanted to fly after the application to assess how effective that was. And 10 days after, they flew and generated this NDRE map, and you can see it does reveal a pretty poor application. The high values that we're looking for as far as NDRE are in blue. So we see it's pretty stripy pattern through the field as a result of the application not having enough overlap between passes. And then we see mid-range values or lower NDRE values in green, which indicates that there probably was a fertilizer ran out and was not applied to that area. So that's something that the grower can go back to the operator with in this case. And another example here, we've got another tree fruit operation. This one is peaches. And for this case, they knew that there was an issue. So they knew that there was a nematode infestation. What they wanted to use the imagery for was to assess what was the extent of the infestation and where should we apply nitrogen, because that was the control method in this case that they were going with. So they used an NDRE map again, and we're able to see that the areas in orange, kind of reddish color, are where the lowest values are. So you use that to guide where they were applying the nitrogen, since they didn't want to apply it to the full field. And they were able to fly 3 months after that kind of targeted application. And we see a lot more uniformity throughout the field. So it was effective in that case to do that targeted nitrogen application. dual camera is building off the RedEdge. So it's taking a RedEdge sensor and we're adding another RedEdge, which we call the RedEdge-MX Blue. So the blue camera has 5 new filters. So we're statically mounting the 2 sensors together, and we're able to align in the post-processing, align those 10 bands. And the reason we did the 2 different sensors is so that our current RedEdge customers can have that option to upgrade their sensor to the 10 bands if they need that spectral resolution. And the same would go for new customers as well. If they start out with RedEdge and then determine shortly afterwards they need to increase the spectral resolution for a project, there's always that upgrade option. When we added the new bands, our consideration there was to correlate with Sentinel-2 and Landsat-8 satellite imagery, since those are really widely used globally, freely available. And there's already a wealth of research that's been done for vegetation management using those bands. So the dual camera is offering a drone-based system to complement that, offering the higher spatial resolution, either to kind of increase ground truthing efforts of the satellite analysis, to validate satellite models, or to have a system that's more flexible if an area needs to be, mapped at a certain time and it's not going to work out for the satellite imagery depending on its orbit or cloud conditions. As far as sample data for the dual camera, you're still able to get the RGB composite and the various vegetation indices. The main additional advantage is the species classification capability. So the 10 bands, the more spectral resolution, the better chance you'll have of doing species classification. And this is a good example of kind of a start for that. We flew this area and generated a false color composite using one of the new RedEdge bands. And you're able to see already, instead of a variation in the greenness, we're able to see clearly the different species in different colors. So we've got 2 different species of tree here, a couple different grasses. So that's something, once those bands are identified where there's unique spectral signatures, then we can generate the classification from there. And this is an example of that completed. So we did this, in this case for the species classification, it was for agriculture, so it was weed detection. And it was a spearmint field where we wanted to identify Candida thistle. That was a specific noxious weed that is an issue in spearmint. Don't want any of that to be harvested with the crop. So I wanted to be able to see not only the large outbreaks of this weed, but any small outbreaks as well, to make sure that there's total control of that before harvest. So we flew this area that was in transition to organic, since we knew there was a lot of weed pressure there, to test the capability of the dual camera. And on the left-hand side, you can see the RGB. On the right, you can see the RGB with the classification layered on top. So we're able to identify not only the thistle in pink, but also a secondary weed, which is wild mustard in this case. So we do have this available on our data viewer as well, if you're interested in taking a look on the MicaSense website, taking a look further and zooming in. The Altum sensor. The Altum sensor is our highest spatial resolution. So that's why you're seeing the bigger lenses there. At 400 feet, you're going to get 5 centimeters per pixel resolution, as opposed to the 8 that you would get with RedEdge. And then the lower you fly, the better that resolution is going to get. We've increased the storage capability for Altum. So it's a USB storage instead of SD card. And then it's our only sensor that integrates thermal. So we have a FLIR lepton that's integrated into the system. The thermal is synchronized in capture with the multispectral. And it is a coarser resolution thermal, so 81 centimeters per pixel at 400 feet. And that's because the primary application there is to use it for irrigation monitoring and for assessing irrigation systems. So I'll show some examples of using that thermal. But first, I want to talk about a overall application where Altum really shines, and that's for field trials. So whether that be for university research or private companies that are generating fertilizers or different seed varieties, Altum can be used from early on in the season to the end of the season to be gathering this quantitative information on the plots. So since you have both the multispectral and the thermal, it's helpful for trials that are looking at, disease resistance or drought tolerance, different irrigation methods, as well as products to increase yield. Flying early on in the season, you can get fly low and get a high resolution for something like early emergence counting, early emergence rates between the different trials. You can also fly later on and get average plot vigor using something like NDVI. And then pulling in that thermal band for irrigation planning, the crop water stress index is something that you can utilize with the thermal band. That's essentially taking the reading on the temperature of the crop canopy you're getting from Altum, and then factoring in what was the ambient temperature during the flight. And that will give you the crop water stress index values. So we've got a service provider in Chile did that with Altum. A kiwi orchard there wanted to trial using the drone mapping for this purpose. Water, they are always looking to conserve water for their irrigation. So they wanted to see if they could clearly generate different zones that needed to be irrigated instead of the entire field. And they wanted to correlate that as well to more traditional methods, of course, to validate the imagery. So they flew with Altum to get the thermal, and then they also did the traditional method, which was to do randomized leaf sampling throughout the field and to do a pressure bomb test on those leaf samples. So there's really good correlation between those leaf samples that were tested with as well as with the drone mapping. So they were very happy with that correlation. This is a good option as far as planning out the different zones and doing the variable rate irrigation. So in this case, zone 0 is showing up as pink. That's the highest stress index values, so the water stressed areas. And then the last example for Altum here is monitoring irrigation systems. So whether it's a drip irrigation system or overhead sprayers. So we've got some examples here. One is the one on the left here is actually a grassy patch next to a pumpkin field. And you're able to see that there's a number of sprinklers that are set in a circular pattern. The coolest areas are showing up as purple. So that's where the majority of the water is being applied at the edge of the circle to be expected. The one area that looks like an anomaly is you're seeing just one line there at the top instead of the full circle pattern. So that's indicative that particular sprayer is jammed and is not completing the full rotation. And on the right-hand side, this field was flown shortly after some water was applied from, excuse me, from some overhead sprinklers. So you can see, again, the coolest areas are in purple. Where we see the anomaly there is the areas that are still kind of pink, so showing up with a higher canopy temperature. So that's indicative those two nozzles look like they're probably clogged or at least partially clogged. So that's what's resulting in less water being applied, therefore it's not as cool in those areas. So that's a brief overview of the 3 different sensors, what they're best suited for. Now I wanted to briefly go over, what's included in the camera kits and what are the drone integration options. So first of all, I'll start with RedEdge and Altum since those kits are pretty similar. So we've got the camera itself that's coming included in a hard carrying case. We also include a lens cover. So that's something to protect the lenses from dust or any scratches when the camera's not in use. And then the light sensor, some cables, namely the cable that's connecting the light sensor to the camera below the drone. And then the calibrator reflectance panel is also included with each kit. Available for purchase separately are the DJI integration kits. So those are our quick mount kits. So they are just connecting to drone power. And we've got kits for the Inspire 2 and the Matrice line. So for the Matrice 100 and 600, the Z30 gimbal adapter is required. That's the gimbal type that works with our kits. So that's just something to be conscious of. The newer models do already come with that, but some older models don't, but it can be purchased separately. The Matrice 200 and 210, we've got a kit for that as well. It does not work with the 210 RTK though, and that just has to do with how we mount the light sensor. And then we do have a kit for the Matrice 300 as well. So I'll show pictures of that, the M300. You can see on the left-hand side how the DLS-2 is mounted on the top of the aircraft. The reason that we do that is to make sure that there's no obstruction as far as shadowing from the drone itself. And then on the bottom, we've got, in one of the gimbal ports, we've connected the camera itself. So there you can see there is space to add a second payload if you wanted to use the dual payload capability. And then another option for the DJI drones is the Skyport. So the Skyport integration comes available for Altum and RedEdge, and that's our most streamlined integration. So you can see in the picture here, it's the Skyport mounting hardware is coming permanently attached to the back of the camera. So it all already comes essentially fully assembled. The only thing you have to attach yourself is the DLS-2 mast to the drone. And the extra capability here is that the drone will recognize the camera and be able to control it and trigger it. So you just have to use your DJI Pilot app to be scheduling the flight. You don't have to set up the camera to trigger itself independent of the drone. It's more integrated through that Skyport. So this is a good option if you know you're going to be using the Matrice 200 and 300 pretty exclusively, and you just want to have an easy, ready to go integration. And then for the dual camera, this kit comes with everything you would need as far as mounting hardware. So in some ways that's similar to the Skyport kit, everything included. However, there's no communication with the drone in this case. So it's just using our quick mount connector like you would with our quick mount kits, except that is connected to a mounting plate, which secures the two cameras together. So that top image there shows everything's coming fully assembled like that. You just need to attach the DLS-2 mount. And there's options. This is the full kit, but there's options as well for the upgrade kit. So those would just include the mounting hardware and the RedEdge Blue camera, and then you can just attach your own RedEdge-MX. And as far as integrations, they're compatible with the same drone models I mentioned. So Inspire 2, Matrice 100, 200, 300, and 600. All right, so to close it out, I wanted to briefly kind of go through some data processing options. At the top there, you can see what the raw images look like from RedEdge, and it would be similar for dual camera and Altum. But essentially the outputs, the raw outputs are going to be TIFF files. So each sensor is capturing a TIFF file every time the camera is capturing. And then it's just grayscale like you see here. And then in the software is going to stack all of those bands and then stitch everything into an orthomosaic. And they're doing the radiometric calibration as well. So either using the panel or both the light sensor in the panel. Both of them will give you that option to choose. For local processing, the options are AzureSoft, Pix4D, and SimActive. So they're all great options and provide a lot of flexibility with how you want to set up your workflow. And then for cloud processing, we've got Aerobotics AirView. So they're focused on tree fruit and tree nuts specifically. So that's what their analytics are geared towards. And they're using RedEdge and Altum imagery. Drone Deploy also uses RedEdge and Altum as far as their processing capability for those that are already familiar and using Drone Deploy. Altea out of France, they use all of our sensors. They've got a variety of different applications that they do. Some of it is plot analysis for like trial plots. Some of it is in forestry, a variety of applications there. And then Pix4D, they offer a great field edge processing solution if you just want to be able to fly and then immediately process at the field edge. And then Solvy as well is a great cloud processing option. All right, so that's what I've got as far as the overview on MicaSense, and we've got some good amount of time for Q&A. So I'll pass it over to Giovanni to help facilitate that.
Yeah, awesome. Thank you so much, Emily. So yeah, I'll open it up now for the questions that we've gotten here in the chat. We've got 18 questions so far. First one we've got here is from Jill Simmons. She asked, can your products be retrofitted to existing drones, or for example, do I have to purchase a DJI drone with it already on it?
Yeah, so depending on what the drone is, if we don't have an integration kit for it, we've got an integration guide that can be used to, if you wanted to create a custom integration. So that's always an option to add to your existing drone. The main considerations there are just, what is the payload capacity? So can the drone carry the weight of the camera? And then what is the power solution? So the DJI kits that I mentioned, they're connecting it to drone power. In other instances, you can have a rechargeable LiPo battery pack and connect the camera to that. So that's definitely an option. And we've got some recommendations on what batteries are good to use.
Awesome. Thank you so much. Okay. Next question is from Jalmar Pachas. He's asking, can your camera find algae blooms in salt water?
That's a good question. We've got a lot of interest in that, specifically for the dual camera, the 10 bands. We were hoping to do some flights for that last year, but COVID kind of disrupted that. So hopefully this summer we'll have some good examples to share. But the theory is that yes, it will be good for identifying that, specifically looking at one of the coastal blue band that have been added for the dual camera.
What kind of depth are you looking at as far as being able to detect those algae blooms?
The algae blooms, what's helpful is that it's on the water surface. So the main consideration for flying over water too is to avoid any sun glint that's like reflecting back up and going to give a bright sunspot. So it's helpful if when the vegetation grows on the surface. We've done that with invasive aquatic weeds before. So you're definitely able to pick up on that with the multispectral. But yeah, essentially it depends if you're looking under the water surface, it depends on how clear the water is. So if it's crystal clear, you're still going to be able to see some of the reflectance from the plants underneath. If there's more sediment and whatnot mixed in with the water, that's going to be blocking the reflectance of the plants below.
Makes sense. Awesome. Next one we've got here is from Kelvin Gonzalez. He's saying, would you check reflectance panel again? Would you check the reflectance panel again after the flight or just before the flight?
Yeah, we'd recommend doing both. So before and after, so it gives you some flexibility in which you actually use when you go to process.
Gotcha. Lorenzo Rhoda is asking, the reflectance panel calibrates the RedEdge. How is the DLS calibrated or verified that all DLS sensors are working?
Yeah, that's a good question. So there's a Wi-Fi interface that the camera has that you can use to like connect with a phone or a tablet. And that's a good, as far as like a checklist before pre-flight, that's a good one that we include on the pre-flight checklist, is to connect to the camera. And on the home page of the browser that will come up is a check to make sure that the DLS2 is connected and powered on. So, as long as that's powered on, it'll be able to capture when the sensor below is capturing. So that's the main check for that. And as well, there's an indicator light on the DLS as well. So it'll be green once everything is connected, and you'll be able to see that once everything is powered up.
Gotcha. Okay. Victoria and Pudu asks, if clear skies or full overcast isn't possible, does the DLS and CRP actually assist in calibrating the drastic light changes?
Could you say that one more time?
Yeah, so she's asking if clear skies or full overcast isn't possible. So I'm guessing like partly cloudy conditions, things like
Gotcha.
that. Does the DLS and the calibrated reflectance panel actually assist in calibrating for the drastic light changes?
Yeah. You'll still be able to do the calibration. It's just as far as how successful that will be, if you find that the output to be usable or not may be variable depending on how drastic that cloud is that's rolling over the field. We have had an instance with a pretty large cloud that rolled over a field, and they were able to correct for it for the most part and like salvage the data set essentially. The only thing was that the very edge of the field did appear brighter. So it's not going to be perfect, but it can take an unusable data set to a usable data set.
Makes complete sense. Okay. Lorenzo is asking if his existing RedEdge-M can use 128 gigabyte cards.
You'd have to check to see the RedEdge-M you said?
Yes, RedEdge-M.
The RedEdge-M. I don't believe the RedEdge-M can, but I'd have to check up on that. It depends too on what the firmware version is. So if there was a firmware update that enabled that.
Got it. Okay.
So that was something you can check with support
Right.
at MicaSense. Yeah.
Right. Okay. Matt Bonsi is asking, are there any specific concerns to be aware of when capturing data on tall timber stands? He's talking about tree heights of anywhere between 60 to 200 feet.
Yeah, I mean, with that, it would just be, making sure you have enough distance, like you can fly high enough that you've, still got enough space below to fly over the trees. So if it's a varied terrain, making sure you have like terrain following on your drone. I would say the biggest consideration for that is making sure you're avoiding shadows as much as possible. So flying when the sun is, directly overhead, ideally. So that you're not seeing the long shadows that the trees would cast otherwise if the sun is lower in the sky.
Got it. Okay. Ken Lucas was asking which camera took the field captures that showed the fertilizer and nematodes.
That was RedEdge. That was RedEdge data.
Got it. Okay. Joe is asking, are the light band sensors CMOS chips or CMOS chips?
Yes, I believe so, for like the 5 sensors for RedEdge. So for the camera itself, not the light sensor. Yeah.
Got it. Okay. Katsutoshi Mizuta is asking, what remote sensing data did you use to collect the 10-band imageries?
I think it was a Matrice drone. I can't remember which model, but that's what we flew with the dual camera for the examples that I showed.
Got it. Okay. Excuse me. Ken Lucas is asking, what software processes the RedEdge mosaics?
Any one of on that last slide. So let me go back. So any one of these will be able to process RedEdge imagery. I would say the most variable is whether or not they support the dual camera. And that's just because that's the newest sensor. So I know all of the local processing options, they can do 10 bands. Altea and Pix40 Fields can do 10 bands, but the rest are focused on RedEdge and Altum for now.
Got it. Okay. A couple of good ones coming up here. So Michael Lacko is asking, do you have some kind of list of which spectral band or combination of bands is good for exact plants? He's saying, for example, for corn, band number 1 and band number 2, for wheat, band number 3 minus band number 4, etc.
That's a good question. It is variable depending on what crop you're looking at, or what species, if it's kind of land monitoring applications, as far as what's going to be best. And there's no specific repository that I know of that has those recommendations set up. And part of that is because too, it'll depend on the growing region as well as the plant species. For some of those initial flights, it is just kind of using the different indices available. We've got, if you look at our knowledge base, we've got some examples of like 10 different indices that are common and how they're generated. But for the cloud processing, for instance, those will already come generated as outputs. So switching between those different outputs to see what's bringing out the most variability as far as plant stress or whatever you're looking for.
Awesome. Cool. Okay. And here's a question I'm kind of interested in because we get it a lot. What is the formula for the crop water stress index? It's been asked many times of us and we don't ever have an answer. So this is good.
Yes, I'll have to look up how it's actually generated, but what I know about it is it's essentially taking the thermal output. So that's got a temperature reading on the canopy, and then what the ambient temperature was during the flight. And then anything that's like 2 degrees Celsius hotter than the ambient temperature is going to give you the highest index value. So that's what's showing up as water stressed.
Got it. Good deal. Okay. That gives us some insight. That's good. So Mark Gaffney is asking, do these sensors integrate well with Pix40 capture and mapper, or must he use DJI Go?
Um, some of that will depend on what drone model you're using, what works best. But yeah, you can definitely use Pix40 capture that will work with our sensors for a kind of standard integration where the camera is set up to trigger itself. That's acting independent from the drone. So the main information you need to feed into the mission planner is just information on like the field of view and stuff like that, so that the drone has the appropriate overlap between passes. So that's the main thing. Most of them will have like Pix40 capture, and the DJI mission planners have an option to add a custom camera. So you would just enter in the information on the RedEdge or Altum, whatever you're using, enter that one time, and once that's entered, it'll show up the next time, and you can calculate the overlap from there. So it's pretty easy for like a variety of the mission planners, as long as they have that custom camera option that you can enter in.
Yeah, awesome. And I know this has been answered, but just for clarity again, Robert Kohlberg is asking, which non-DJI drones are your sensors compatible with?
Yeah, so there's a number. In the US, I know Aerial International, or Aerial Technology International, ATI. They're local to the Pacific Northwest here. They're in Oregon. So they've got a quadcopter called the Bot that integrates all of our sensors. So that's an option. In California, TerraView also has a drone that has pretty long flight time, so long endurance quadcopter. Up in Canada, the Dragonfly has their Commander. So that's another option for RedEdge and Altum. And then there are a variety of, one more I'll mention too. In Brazil, Nuvem has the Spectral 2. They just came out with the second version of that. And that's has a really nice integration for RedEdge and Altum. So those are some good kind of quadcopter options. And then on the VTOL side and the fixed wing side, there's like Quantum Systems has their Trinity that carries all of our sensors. The Wingtra 1 has a RedEdge and an Altum integration. SenseFly has their EBX has a RedEdge integration. And then Atmos UAV, their Maryland VTOL, they've got a RedEdge and an Altum integration. So yeah, I'm happy to follow up too if there's any questions about that. Maybe we can send out a list to those that are interested.
Yeah, that's awesome. That'll work. Yeah, we've got a lot of questions still, man. This is great. So Saeed Homayuni, I'm sorry if I'm misspelling your name. I apologize, or missaying your name. Is it possible to have a configuration of RGB, thermal, and 10-band sensors all installed on a single drone platform? The reason he's asking is he's saying that they're looking for agro-environmental mapping / monitoring.
Gotcha. I am not aware of any drone that could do 3 different payloads. I mean, potentially on like a Matrice 300, if you had a custom rig that you set up to have the cameras all mounted and able to power together. However, there might be some issues there as far as getting them all to trigger simultaneously so you can align the data sets. If you wanted to use Altum, that's the synchronized with the thermal and the multispectral, so you could get those 2 outputs from the one, and then on the second payload you could fly with the high-res RGB. So that's definitely something people are doing with the 210 and the Matrice 300, or any drone that can do the dual payload.
Got it. Okay. Next one we've got here is from Andrew Robichek. Again, I apologize if I'm butchering your name. He's asking, can Esri-based software be used for image analysis?
Yes. Yep. You can definitely do that to like create the false color composites or indices and do the further analysis once you've got the geotiff. Yeah.
Awesome. Good deal. Okay. And Arun Govind is asking, how does the MicaSense NDVI compare to S2 or L8 NDVI?
I don't know that I'm familiar with the other two NDVI that were mentioned. But the NDVI you're going to get from RedEdge is using the near infrared and red band that I mentioned. So, looking at the center wavelengths of those bands would give you a little bit more information onto what you're getting there. So I'm not sure if those other ones maybe use slightly different bands as far as like where the center wavelength is, but.
Cool. Okay. This is a good one. When it comes to stand count, this is from Charles Buckles. When it comes to stand count, what's the best AGL?
Yeah, so that'll depend on how big the plant is. And because you want to make sure that you're going to get ideally, at least a couple pixels per plant. So considering that, then you can go from there to determine what AGL you need to fly to get that resolution. So for the example that I showed earlier, when we did like the early emergence counting, we flew pretty low. I think it was like 20 meters. And we got a 0.9 centimeter per pixel resolution because the plants were so tiny. So yeah, it'll depend on how big the plant is.
Got it. Okay. So I've got a question from Robert Polson here. Is the M300 RTK accuracy inputted to the image metadata using the Skyport?
No, it's not currently. So the RTK can't be inputted into the metadata. So what the RedEdge or Altum would be using is the DLS2 for the geotagging.
Got it. Okay. And James Newton is asking, well, this one's real simple. How difficult would it be to attach the RedEdge to the Inspire tube? Not difficult at all, I don't think.
Yes, yeah, not difficult. We've got that quick mount kit, so it's pretty simple.
Quick mount kit is a lifesaver.
Yep.
Cade Krieger is asking, does mounting void your drone warranty? It depends on how it's mounted, I would say.
Yeah, exactly. Yeah, it depends on how it's mounted. Like for instance, I know some people use like the Phantom 4 to fly RedEdge. And so for that, you don't want to be removing the integrated RGB sensor or anything that would void your warranty. So I've seen some integrations where you're, snapping on to a basically completely independent mount that snaps onto the legs of the drone, right. So that you don't interfere with any of the wiring that would. Anytime you're opening up the drone, you're probably going to be running into some territory where you might be avoiding their warranty. So yeah, any integration kits you want to look at, either like we have with the quick mount, where it's something that just like twists, locks onto the drone. And then you've got like just like screw on the light sensor. So you're not messing with the electrical in those instances. You're using how the drone is already set up with the gimbal port for power.
Yep, correct. Yep, cool. Alexander Escobar is asking, in the Altum model, the DJI Skyport with the gimbal, if it's going to be available for the Inspire 2.
No. So the DJI only offers the SDK communication capability for the Matrice 200 and the 300.
Gotcha. Okay. So Ken is asking, will the RedEdge camera be triggered automatically via drone deploy app, or I'm sorry. Will the RedEdge camera be triggered automatically via the drone deploy app to allow creation of a mosaic in PixMapper? I'm guessing it means Pix4D Mapper.
It wouldn't be through the mission planner. You can't set up the triggering through there. It's going to be the camera set up to trigger itself. So in the mission planner, when you're entering the custom camera and setting that all up, that's just for the drone overlap calculation. So it's not doing any communication with the camera in those instances, but you're still getting the same output, which is you're going to get those raw TIFF files that then you can process in Pix4D.
Gotcha. Okay. And we've got a few questions asking for example data for golf courses or hail damage, things like that. What we'll do is send those questions to us, and then we'll field them to Emily, and we'll try to get you that data. Okay. Brendan is asking what VTOLs pair well with the 10 band setup.
Currently, the only VTOL that works with dual camera is the Quantum Systems Trinity. So that's a great option. And they've got the, I think, max like 90-minute flight time too.
Right.
So you can cover a good amount of area with that. Yeah.
Right. Yeah, it's a great drone. Really good drone. Scott Harrigan is asking a question that we have not answered actually. Are you able to match certain surface pollutants with certain bands emitted by the multispectral? Or captured by, I should say. Yeah.
Yeah, that's a good question. It'll depend. So typically for kind of new applications like that we haven't tested before, it's my first step is to do kind of a lit review and see if there's been any research that's been done for that specific substance, whatever you're looking at for this bill. So to see if there's been any research like with hyperspectral imagery, for instance, to identify what bands are good for picking up, the reflectance from that specific substance, and then seeing does that correlate with the bands that we have. So that's a kind of good first step because that's not something I'm familiar with, unfortunately.
Gotcha. No worries. Skylar Peterson is asking, could the Altum and the MX Blue be used in tandem to provide more in-depth analysis per flight, parentheses, agricultural purposes?
Mm-hmm. Yeah, so the blue is really just to connect with the RedEdge. So we don't have an option to add it to sync it up with an Altum. So the reason we're able to do the simultaneous capture and do the alignment in post-processing is because we know the rig relatives for the RedEdge, and on the firmware side, we've got it set up to work with the RedEdges, but that's not something that's been unlocked for Altum.
Got it. Okay. And Muraldahan, I'm so sorry, is asking, can you explain how the information collected from the drone is sent back to a central database for future reference / study? That's something that you would do on your own. You would, I mean, correct me if I'm wrong, but you would just get the SD card, put it into a PC, and then just upload it to a cloud service, however you'd want to do that.
Exactly. Yeah, that's the workflow. It's all stored on the SD card with a USB stick, and then you can take it from there.
Right. Okay. Eves Lanton is asking, this is a different question for an SD card. Can a 128 gigabyte SD card also be used with the RedEdge-MX from last year, or only the latest ones? Maybe a firmware update is needed?
Yeah, exactly. It's the firmware update. So if you've got the MX model, I know definitely it'll work with that. You just got to make sure you've got the latest firmware.
Got it. Okay. Another question from Robert Polson. Are you considering direct georeferencing in combination with the RedEdge and or Altum? He's saying it's particularly interesting for coastal applications.
So as far as like a PPK or RTK integration?
Not much other information there, unfortunately. Maybe he's got something down here. No, I'm really not sure. I apologize.
Okay. Yeah, I mean, as far as for the PPK side, there's a couple of different companies that do integrations with RedEdge and Altum. So they've got their own, systems that we've worked with them and they've integrated. So like, for instance, Field of View has a PPK system. Alanix, BAMTech, they also have a PPK, and they do integrations with like some DJI models. Yeah, so there's a couple different options for that. And then if you've got like ground control points and you want to use those, you can definitely use those as long as your processing software can handle those, and you survey those in advance. So that's an option for sure.
GCPs are always good, definitely. Marion is asking, how can the Altum thermal band be used to detect irrigation issues and insect infestation in crops?
Yeah, so the thermal band, some of the examples that I showed, basically you're able to identify areas where the soil is more waterlogged by correlates with the lower temperature. So that's how you're able to identify any leaks in the irrigation system or inefficiencies with how the water is being applied. So it's good to fly shortly after the water has been applied to heat, so that you have the maximum difference in temperature between areas where water has been applied and where it has not been. Other than that, flying to look at like crop water stress, that you'll be able to see the areas where the crop is hotter. That's going to correlate with the plants that are water stressed. And then what was the last part of the question? I'm forgetting.
And insect infestation.
Insect infestations. So I haven't seen the thermal be used too much for to identify, insect pressure. But I know that for like forestry, for instance, there's certain diseases or pest pressures that will cause the trunk of the tree to get hotter. So that is something that you could see in the thermal. For instance, you're going to see hotter in the crown of the canopy in the center of the tree, and cooler temperatures for the branches. So there's potential there, but it depends on what is the pest and what are the first kind of signs of stress that are caused when that pest pressure is on the plant.
Makes sense. Okay. We just got a couple minutes left here, guys. So I'll just try to take some questions that maybe we haven't answered yet. Igor is asking about firmware update when using the dual camera system. He's saying, do you need to update the firmware in both cameras separately, or updating it in the main camera takes care of the MX Blue as well?
That's a very good question. I actually don't know the answer to that. I'll have to connect. I'll have to connect with our support team.
No worries.
Yeah, I mean, we can get back to you on that one. I want to double check to make sure. But we've a good place to check about that actually is we've got our knowledge base, support.micasense.com. So that's a great place to just use the search functionality and look at look up firmware update, and we should have instructions on that.
Got it. Perfect. I'll put that up in the chat. So it's support.micasense.com for your info. And then we've got Zach Ansley. I'm sorry if I apologize. I suck at saying bad last names. Which sensor is best for identifying different plant species?
Yeah, for that, the higher spectral resolution is going to be helpful. So the 10-band dual camera system will generally be best for that. We found that in the examples that we've been able to fly ourselves, having the 3 red edge bands is especially helpful for species classification. So dual camera. Yeah.
Awesome. Okay. And then you have Sandil. So this is a question I've seen before. And it's not necessarily an issue with the camera, it's just how it's kind of set up. Do you have any tips on avoiding banding that can sometimes be seen on mosaics?
Yeah, actually, that's a really good one. I'm glad it was brought up. Generally, what we've seen, if there's banding, it can often be because it was a sunny day and you use both the light sensor and the panel for calibration.
Yep.
So in those cases, if you're getting that, just use the panel. So a lot of times that will help it. Essentially, what's happening is there's really not much change in the illumination. So the DLS2 is kind of overcorrecting in those cases. So that's why the DLS2 is really meant for cloudy conditions. Yeah.
Yeah, that's one thing that we've seen. It's just better to just use the calibration panel. Forget about the DLS. That's really where the bulk of it is going to be. It's just use the calibration panel. You'll be good to go. Mm-hmm. Let's see what else we got here. Okay, so Ken is asking, this is an okay question. Does the RedEdge geotag each pick automatically?
Yes. Yep. So it's written into the metadata, and we've got a GPS embedded in the light sensor. So that's what it's using for that. Got it.
Okay. All right, guys, thank you. I apologize. We've run over time a little bit here. Thank you so much for attending, everyone. I really want to thank Emily for joining us, and you guys especially. thank you so much for attending the webinar. We couldn't do this without your support. And any other questions that you guys may have, please direct them to us, and we will field them and send them off to Emily, and hopefully we can get those answered for you. Okay. But again, thank you, Emily. Thank you for joining us. And
great to join everybody.
yeah, and thank you guys again for coming on and attending with us. Okay.
All right. Have a good one, everybody.
Thank you, guys.